So this is a two-part question. The first part asks us to prove that the sine of 2a is equal to 2 sine a cos a. So this would be a formula that we would see quite a bit when we're solving trig equation and identity questions, but not necessarily one that we'd be asked to prove before. It's not technically one of the 8 prescribed trig proofs that are on the syllabus, but they have asked us to prove some identities outside of those in the past, and so it's just something you have to think on your feet and kind of be aware that you can be asked to prove trig identities beyond what's prescribed, let's say, in the syllabus. So the sine of 2a equals 2 sine a cos a. So we're going to start with one of the trig identities that we are asked to prove, which is the sine of a plus b is equal to sine a cos b plus cos a sine b. And if we amend this formula very slightly, we can end up with this identity up here that we're trying to prove. So the sine of a plus b is equal to sine a cos b plus cos a sine b. If we were to change that b and make it an a also, and then obviously if you're changing a b in the formula to an a, that means any other b's in the formula have to be changed to a's. Well, then we've created the sine of a plus a, and the sine of a plus a is the sine of 2a. Now, the sine of 2a is equal to sine a cos a plus cos a sine a, and well, there's two of those, so that's 2 sine a cos a. And so that's the proof done. It's very short. It's worth 10 marks, which amazingly the second part, which is a lot more difficult, is also worth. But I suppose this part is difficult in itself if you didn't kind of see something like this before. But some of the proofs that we have been able to derive have used this idea of changing letters to other letters and then getting down to the final line of your proof, let's say. So the second part of the question then presents us with a triangle, and they give us a massive hint in this question. They ask us to find the cos of w as a ratio in the form p over q, where p and q are natural numbers. But they do say to use the result from b part 1, and they do say to use the sine rule. So what have we been given? We've been given an angle here that's w, and we have an angle over on the other side that's 2w, and we have the opposite sides of those. So the side that's opposite the w is 3, and the side that's opposite the 2w is 5. So if we set up the sine rule is on page 16 of our formula book, and we can use it like this, or you can also turn it upside down. I've seen students write the sine rule as sine a over a equals sine b over b, and you get exactly the same result. And the sine rule says if we pick a side and put it over the sine of its opposite angle, that will be equal to any other side over the sine of its opposite angle. So I'm going to pick 3, and I'm going to say that 3 over the sine of w is equal to 5 over the sine of 2w. So at this stage we're going to cross multiply, and I'm going to get 3 sine 2w is equal to 5 sine w. Now we're trying to end up with the cos of w, and we might be looking at this thinking, how are we going to go from something that has the sine of 2w and the sine of w to something that has a cos w? And the big hint in the question is that we're going to use the result from b part 1. And the result from b part 1 was that the sine of 2a is equal to 2 sine a cos a. That means that the sine of 2w is equal to 2 sine w cos w. So we're going to replace the sine of 2w with that. Now at this stage we can tidy this up. We can say 3 times 2 is 6, but also we can divide both sides by sine w. Now we have to be careful dividing both sides by 0 because that's not allowed in maths, but clearly sine w isn't 0 here, because w is an angle, and it has a measurement. It isn't a measure of 0, because we're making a triangle out of that angle. So if we divide both sides by sine w, we're left with 6 cos w is equal to 5, and then we're asked to find cos of w, so we're going to divide both sides by 6, and we get cos w equals 5 over 6. And that's it, done. We don't have to do any more work. They ask us for cos w in the form p over q, where p and q are natural numbers, which they are. If we had been asked to actually find the angle w, well, the angle w can be found by finding the cos inverse of 5 over 6, and if we throw that into our calculator, we get 33.56 degrees. But they don't ask us for that in this question, so it's not necessary. There is other questions in past exam papers like this where they ask us to find an angle, but find the angle in terms of the ratio cos w is equal to 5 over 6. Okay, 10 marks for that one as well, and a lot more work in that than the first part, but there was 2 hints. One, that we had to use this sine double angle ratio, and the second hint was that we had to use the sine rule.